You are in the right place if you're here for our webinar on queries. My name is Paul Taubman with 9.connects, and we are going to get on with it here because we have a lot to cover in this 1 hour. First and foremost, we're going to talk about the categorization of the various queries that Altium presents in its query helper. And there's well over 600 of these queries. And obviously, we're not going to be able to go through all of them. But if we understand how they categorize them, it may make it easier for you to find them. We'll also talk about the various operators that we can use. A lot of times we do have to do logical functions in order to make sure we're selecting what we want to select. And then lastly, we'll talk about these useful queries, or what we consider to be some useful queries throughout the presentation. And just note that this is a really small subset. Again, with over 600 queries that happen to be in there, we certainly can't go through all of them. And a good portion of them are kind of esoteric anyways. So let's get on with it over here. We will have some time for some questions afterwards. But in addition to that, we do have some collateral for you as well. So in addition to what you're going to see in Altium Designer, we have put together what we call the query spreadsheet. And it is still a work in progress because we are trying to go through each and every single query to understand what it brings to the table. And we've unearthed some really cool ones that hopefully you'll see here today. But in addition to that, we're going to make it available to you on our website. So if you're interested in it, feel free to download it. Let's give you a quick little look here. So what we did was we copied those things out of the query helper, but we've been adding some additional information in here as well. What we're trying to do is make it in such a way that you don't have to keep going back into Google or TechDocs in order to try to find what the query is all about. And some of them, they don't really give all that great of an explanation anyways, and that's what we're trying to determine and understand. And this is what is available. As I said, we're going to continue to work on it. We just have a lot to go through in order to fill in all of these particular blanks, and we hope that you'll find that useful. With that being said, let's get on with it. So a couple of thoughts on queries before we dive into the different categories. Queries have 4 primary purposes. They are to find and select, which are almost synonymous with each other, though you can find without selecting. That's just called highlighting. But selecting is so that you can perform an additional edit on it thereafter. There's also the applying of rules, and that's probably why most of you are watching this here today, is because you're trying to put together a rule above and beyond those tools that Altium provides you. And of course, they can be used for scripting, which we're simply not going to cover in this particular topic today. We just want to focus on the queries. There are also query sets for the schematic and the schematic library as well, but we simply won't have time to look at them. But if you understand how they set it up here on the layout side, hopefully if you use the schematic filters, you'll see that the queries probably have a similar structure as well. Last time we talked about this, we've done a 3-part series. This I consider to be part 3 of our revisit of the DRC. But in part 2, I talked about these queries having either to be a Boolean or they are an expression. And that's partially true. So I want to clarify something here. All queries are Booleans. Some of them simply do not have parameters. Those are my favorite. Those are the easiest ones to use. They're very quick and easy to put into the filter because Altium is going to provide you that keyword set that you can easily find in a list. Click on it and you're done. But then there are also Booleans with parameters. And some of them are numerical, some of them are string, and some of them are enumerated. And I'll talk more about those here as we go through the categories. There are basically 6 different categories, 7 if you want to include what they call system functions, which are the math operators and functions. I'm going to go through all of these here. You'll find all of these in the query helper, and that's where we're going to focus our attention here for the next couple of minutes. We want to look at each one of these categories here and understand why Altium did it the way that they did it. And once you've got a feel for that, hopefully it'll allow you to find those things that you're looking for within the queries. So let's jump out here instead of looking at some PowerPoint slides. So we're in Altium Designer. And by the way, as a part of our collateral, you can see that we've also put together a project. So we are going through each and every single query. We're trying to find an example of it, and we're also trying to put it into one of the layout PCB docs in order to categorize them and to make them available. And that's what we're doing over here, is we're just trying these out so that we can see what the result is when we type those things in. Now, what about finding the entire list? Well, that's under the PCB filter panel. That's going to be in the layout editor. And you're going to see something called the helper, which is called the query helper. These are the functions that we're going to be taking a look at here today, so the object type checks and so on and so forth. What we're not going to look at today are those things in the PCB object list. And as a matter of fact, these should be pretty straightforward because what these are going to represent are those items that are already in the layout. So if you already have nets, they're already going to be in here. If you have pads, they're already going to be in there, and so on and so forth. This, of course, is going to change for every single project that you do. So it's a nice place to find these various objects. The system functions, which we'll talk about, I kind of clumped these all under what I'll call mathematical expressions, and we will talk about those as well. And quite frankly, I'm not necessarily sure why they put them down over here when they tend to be more kind of like PCB functions, or at least they assist with the PCB functions, or at least put them above the PCB objects list. But let's not question Altium's organization of this. We'll take a look at them. The first area that we're going to look at are the object type checks. What's interesting about this entire list here is that they all represent something that is graphical, that you can see on the screen. Most of these have the verb is in front of them. Some of them do have has. And most of these, almost actually every single one of them with the exception of one, which I'll show you, do not require additional parameters. And that's what you do is if you go through this list and you're looking to highlight something or select something that is specific to your layout and it's a certain type of primitive, this is where you can go in that list to find those type of things. So for example, if we type in is pad, and we'll click on that, and you'll notice that it does try to do the autofill to assist us here so we don't type in bogus keywords. So it finds all my pads. Or what about is track? There we go, is track, and I press apply to all. So now it's selecting those things that are tracks. Now, of course, these are selecting all tracks that are on all layers. And later on, we can talk about logical operators so we can further define what we're specifically looking for. But these all come from that list here under object type checks. And by the way, and we talked about this, I think, momentarily in the second part of this Revisit DRC webinar series, is rule. And oddly enough, you can represent a rule through a graphical representation. It's something we stumbled upon through our investigation. Well, if you remember, there's kind of an interesting feature in Altium Designer called rooms. Rooms are not defined as your typical type of primitive. In fact, you click on it here and you'll notice the properties say, click here to display all the objects. It has nothing to display. So what is it a property of? Well, believe it or not, it's a function of the design rule checker. So if we go into design and we go into rooms, pardon me, let me go into design into rules, you will see down here under the placement category queries, this is where we actually create the room. So it's actually a function of the rules. So as a result of that, if I am to type in is rule, believe it or not, it will actually select our room. And all of the other things that they list over here would be based upon those rooms being in certain rules. So if we go back into our object type checks, you'll notice there's a huge list of these is rules. So if these is rules happen to be a part of a regional rule, that's what we call them here at 9.connects, a regional rule that's under a room, more than likely you can have a graphical representation of it. There's only one that I have yet to find the representation for. It is called is class. So in this entire thing, there's basically a physical representation for all of these except for is class. And that's not to be confused with in class. So here's one that says is class. The problem with is class, and maybe there is some type of graphical representation for it, I'm not sure what it is just yet, but don't confuse it with in class, where in class is a membership. And if there's something like a net class, well, what do we have in the class? We have nets, and I'll show this in a few minutes. But what you have is you have nets, and because they're real, it will select those things that happen to be a part of the net class. But if you ask for something that's called is class, there's no graphical representation, at least that I know of, that will immediately pop up or that we can present here that would highlight. Now, as I mentioned earlier in the objects list, all of them do not require any additional parameters except for one of them. And let's bring this up over here. So under object under object type checks, what we have over here is one that's called is object kind. So let's go over here and take a look at this one. So there it is. But it doesn't give you a hint that this actually requires additional parameters. And by the way, again, this is what we're trying to put in our Excel sheet is to determine if it does require additional parameters, and if so, is it string, numerical, or enumerated. Nevertheless, let's take a look at this one. So when I do something like isObjectKind, if I simply press apply all, it's going to bark at me saying, nope, I need more information. And ObjectKind is kind of an odd one because it doesn't require an equal sign. It's actually acting more like a function. And what we need to do is type in what type of primitive we want it to find, or actually in Altium they call them objects. So I'm going to hit apply all, and sure enough, it finds all my vias. If I go in here and I type in isPad, then if I hit apply all, it finds all of my pads. Now you can certainly make use of this, but I'm going to be perfectly honest with you. What you're going to find in the query language is that there's a lot of what I'll call synonyms, those things that are equivalent to each other. And if I can get away without having to type additional information, all the better. So I can still, for example, type in isPad, and I'll get the same result. So here's isPad, I do apply all, and there's my pads, as opposed to typing isObjectKind. So sometimes if you find that you're doing something that's a little out of the extraordinary, take a look around, because there might actually be some type of query that will do the same thing. You'll see a really great example of this later on when we talk about the mathematical functions. So that covers the objects. The next area we're going to look into are the fields, and this by far is the largest of the list. So what are fields? Nice way of saying they're basically properties. And some of these properties are very, very specific to certain objects, and there are other ones in here that are very generic. So you can see, for example, you have arc start angle, arc stop angle. So these are very specific to an arc object, as opposed to something like x1, y1, x2, right? y2 here. These are something that pretty much everything would have, because there has to be some type of graphical location for it. And what it will do is that if it is applicable to a particular object, then it will apply it, and if not, it will just kind of ignore it. So if there is something that does not have, let's say for instance we have a mathematical equation that requires both x1 and x2, and if something does not have both x1 and x2 in it, then it's not going to try the query on it, it's just going to skip it. You'll also notice that a number of these in here get repeated over and over again. So instead of, for example, of Altium creating a mid layer where they type in some type of value for the mid layer, they've actually have a hard-coded query for each and every single layer. This happens to be with the via size. They also do it with the pad XY size, the pad X size, the pad shape, and I think the pad corner radiuses as well. So there's a lot of hard-written queries in here that they, instead of trying to just say, hey, pad corner radius, and then you put in a mid-layer name or some type of name, here they brute force it. So you have those in here as well. One of the things that's really interesting about this particular set of categories, and it makes a lot of sense since they're properties, is that very few, if any of them, are going to be a straight-up Boolean. They are going to require some additional parameter, which makes sense because when we have a property, we also have some type of value for that property. Otherwise, why bother having the property? And that's what we're going to demonstrate here right now. So let's take a look at this. So the first type I'll talk about are those that have numerical values. So arc radius is a pretty decent example. So here's arc radius, and we can use our logical operators. We can say equal to, less than, greater than or equal to, or less than equal to. We can use any one of those things if you want, but let's just say that we're going to do it greater than 10, and we do apply all. And now it does find those arcs that have radiuses that are greater than 10 mils. Now, one of the things I do want to show you, and hopefully you'll find some use of this, is that this can actually be somewhat deceptive, especially if you are jumping between imperial and metric. So how do I tell this that I want 10 mils and not necessarily 10 millimeters? Well, one of the features they've got in here is called as. And if you look at it, I'll type in the next letter so we can get the A sign out of there. But here it is. We have as mils and as millimeters. And in order to use this, you actually wrap it around the query, not around the number. So if I say as mils, then what I've got to do is put arc radius into parentheses, and I apply all, and then it will make sure that even if I hit the Q key and jump into the millimeter grid, that it will still recognize this 10 as mils and not as millimeters. So a very useful feature that you can make use of in these objects here. So another type of parameter that you'll come across are those that have to be typed in their strings. So if we do in component, This one can get a little tricky, and you'll see why here in just a moment. Actually, I don't want to do in component here. I just want to do component. So again, you can see there's some equivalents that we're going to be seeing here today. Here's component, and if I'm going to use this one, I have to spell out what the string is going to be. So if I do it as designator 6, and I hit apply all, then it should have selected this. Now, actually what is going on over here, and this is what I've got to be careful of, is that I have to type this in specifically. And that also means it has to be case sensitive. And in this case here, I accidentally put in a space and I shouldn't have. So if I now hit apply all, it will now find it. The point I want to make about this is that the keywords, or the queries, they can be put in caps and lowercase. Basically, they're case insensitive. So if I do component, get that N in there, and we press apply all, it will still select it. Let me just clear it so I can prove that to you. There it is. It will still select it. But anything between the two single quotes, those have to be, they must match literally, or they will not work. So if I go in here and I say lowercase d for designator, if I hit apply all, it won't work. It has to match verbatim. Okay, so that's an example of a string value. The other one I want to talk about is what I'll call string/enumerated. So it also is a string, but it's also an enumerated type because it comes from a list. And a really good example of this is one that is called the component type. And I'll just go into a little brief extra about this because I don't know if we've ever really talked about this in any of our prior webinars. But every single footprint and symbol have something that's called a component type. This one for P4 is actually set to graphical. That's kind of not realistic for this here, but I did this just for grins. What these are here are some instructions to Altium during the ECO process from the schematic side to the PCB side. And what those instructions are, number one, should it be in the bill of materials? Number two, should there be a footprint that it needs to go look for, and if it can't find it, it needs to squawk about it? And number three, is there a rule exception that we need to make because we have either a jumper that we need to put in where we don't want to put down copper between two different points that are supposed to be connected, or we want to actually short 2 points specifically. And that's what this particular list does. And this is a great example of enumerated type. We can't put in anything else. We can't type something else in here. Let me go through these rather quickly. We did just to make sure that everybody understands what these are. I think it's really good to know where these are coming from. A type standard part, which you'd use probably 95% of the time, if not more. It means it has a footprint, and it also means that it's going to be put in the bill of materials, and that there's no exceptions to the rules. That it's a standard footprint, and that if you're going to place these things down, it's got to adhere to whatever rules that have been created. There is also type mechanical. What mechanical is are those things like heat sinks and other items that don't have a footprint, but they are supposed to be in the bill of material. And in certain cases, like with the component, what you call the component clearances, they would expect to adhere to the rules. The next one, which you'd really never see here on the PCB side, so I'm surprised that they even allow it, is one called graphical. Graphical is simply just some type of picture, like it's a logo. Maybe you have a logo of your company in your symbol library, and you place it on your schematic, but that's as far as it's going to go. Okay, there's no ECO process to go look for a footprint and place something onto your design. Okay, if you're going to do that, you may as well do standard no bomb at that point. But graphical means no further actions be taken for the ECO. It's not going to find its way in the bill of materials. You have net ties. These are for things like inductors or little shorts that you purposely have put into the component that Altium's going to squawk about because you have basically two nets that are shorted together. So yes, you can go into the rules and you create a short circuit rule that allows this, or you can use what's called a net tie, and Altium will just understand that these 2 points are supposed to be electrically connected together, though they have two different names. There's also one called net tie and bomb because most of these net ties are generally features in the copper. But if there has to be something that needs to be added into that, so for example, if you're doing a planar inductor and you need some type of core material, then you can make sure that that core material finds its way into the bill of materials. There is also standard no bomb. So it does put down a footprint. It's still supposed to adhere to the rules, not that there's really anything there, but it is not supposed to be in the bill of materials. And lastly, the jumper is pretty much the opposite of the net tie, where you've got 2 points that are represented by the same basically the same net, and Altium's going to squawk about them being antennas or that they're not connected, but the jumper says it's okay. These do not have to be connected via copper, and that's what the jumper is all about here. So I know I went off on a little bit of a tangent, but I figured I'd talk about this because I don't think we've ever really covered it before in another webinar, and it's just a little esoteric, let's call it an antidote that might you'll find useful here. So anyways, where are we going with this? There is actually a query that helps us define those type of things. So what we can do over here is we can type in, we'll type in component type. Here we go, we'll type in component type. And again, I've got to give it some information. So I'm going to type this in, and I'll type in type standard. You don't need that. We could, by the way, put this in parentheses. There's no reason to do so. I'm going to press apply all, and it finds those things that are now of type standard. As I mentioned before, if you are not careful about how you type this, it won't find it. So if I do a lowercase s and I do apply all, it doesn't find them. Okay, so there you go. There's component type standard. I think the other one that we had was either graphical or mechanical. Let's see which one it was and see if it works here. So I think one of these was set to mechanical. So we'll do that over here as such. And if we do apply to all, boom, it found it over there. And of course, it's going to squawk about something here. So let's just reset that here just as a quick recap. If I want to reset the DRC markers, I can go into the tools, reset error markers, and boom, it's done. All right. So hopefully you have a feel for what's going on with these fields over here. There's a number of different things that you can make use of. I just wanted to give a little taste of the different things that you can find in there. The next one is where I think a lot of the really great keywords exist. Actually, before we do that, I'm thinking about attribute checks. Let's talk about membership checks. Membership checks are certainly important because a lot of the primitives that we use in Altium Designer are a combination, and I should call them primitives or objects. We take a lot of objects and we put them together to create another type of object. We do this all the time. We do it primarily in components. If you think about what a component is, it is basically defined of a number of smaller primitives. We put pads in there, we put tracks in there, we put arcs in there. They may be on different layers. That's what they do. So let's take a look at that for a moment. Let's clear this here. And if we go into the PCB panel and we click on components, and let's take a look at all these components. Well, here's a good one. Here's this crazy one that we created called Designator 6, and you can see all the primitives that make it up. Well, that's the same thing that's true for classes, the same thing that's true for rooms, same thing that's true for unions, same thing even for polygons. That's why there's a difference between an is polygon and an in polygon. As a matter of fact, if you do a electrical clearance rule, you've got to use in polygon, not is polygon, because the polygon is actually made of different regions and different fills. This is more obvious in a hatched polygon, but in a solid one, even though we can't select the individual fills that might be making those polygons, making those things up, the fact of the matter is they are actually made of certain different copper primitives that come together to make that polygon. That's why we have to use the one that's in polygon for those type of rules. If we go over here to the PCB filter and we go under helper, let's take a look at what we've got. So we have membership checks. By the way, there's the as mils and as millimeters here. So I gave you guys this a little bit earlier than later, but that's fine. Then you'll see all the different things that you see in here. So a lot of them happen to do with classes, or you see ones for union or things for the polygon, okay, and so on and so forth over here, even for rooms as well. Just to give some quick examples. And one thing I do like about using the membership, let's try that again. One of the things I do like about the membership checks is that it tries to fill in all the blanks for you, because in theory they're supposed to already exist. So if we do something like in component, not component like we did last time, but in component, and we click on it over here, guess what it gives us? A list of all the components in our layout. So here I go, Designator 6. So I didn't have to try to type this in on my own and worry about syntax issues. I just hit apply all, and boom, I'm done. The same thing is true for in-net component. Pardon me, not in-net component, in-net class. So if we go to a class one, but even in component class, this would work as well. I don't have any component classes, but let's take a look at in-net class. I created one called query nets. So there it is, and I press apply all, and sure enough, it selects those things that happen to be a part of this net class called query nets. So that's the membership checks. Very useful to use when you're trying to group things together. The next one is the attributes. And the attributes are interesting creatures. They are very, very similar to properties. And as a matter of fact, I think there's almost a kind of a blurry line between fields and attributes. But the major difference between the two is that fields are pretty much properties of something, whereas attributes can be properties of something, but it's really more about the characteristic of it, not necessarily the property of it. That's really a better way to say it. For example, one of the things it can do is it can look, when I say it, I'm talking about Altium, can actually look to determine what type of package might be used. So you'll see things like in BGA, in DIP, in LCC, in PGA. There's quite a few of them. It'd be nice if they were all listed in the same area, but obviously it's in alphabetical order, so they're kind of scattered about. What's interesting about all of these ones that can find the packages has nothing to do about the label, the footprint name, when I say label, or any type of parameter that might have that information in it. It's actually based off of the structure of it. So it's looking for, again, characteristics. So let's take a look at this over here. This is kind of an interesting thing that we've been diving into. Let's go over here to this particular page. We call it the components page because this is where we're doing our experiments on these things. So let's do one that's called is PGA. Let's click, try that again, PGA. And when we select it over here, it does find 2 of the 3. So if you go into the tech docs and you look for something like is BGA, it gives you the definition of what it's looking for. What are the minimum qualifications in order for Altium to select it? Again, it has nothing to do with the name. It has to do with the number of pads and the rows and the columns that are set up. Here's an example that one of the requirements is it has at least 1 through hole for this thing to be a PGA. So I put 1 through hole in there, tested it out, and guess what? It works. Here's a BGA, which would be, well, this is really more of a PGA rather than the BGA, so we do need to change the name on this over here. The point I want to make is these would be all through holes as opposed to a ball grid array like this here. And there is one that's called is BGA as well. This one didn't get selected. So why did it not get selected? Because it doesn't have enough rows and columns to adhere to the definition. Another example of it are the SIPs. So let's take a look at that one. Let's clear this here. And we do is SIP. And we'll do apply all. So again, what we're seeing over here are the rules. Well, let's say the boundary rules for the query. The query required at least six types of pads, 6 pads. I think it could be, at least one of them has to be through hole. But there had to be 6 in a row or 6 in a column. So I started playing with this, saying, well, okay, well, what happens if the column, or pardon me, the row is a little goofy? And it seemed like it was doing a pretty good job of it, but you'll notice down over here, SIP number 6, when I did put something below it directly, it wouldn't flag it. And of course, this one here, SIP 3, wasn't qualified because it only had 3 pads as opposed to 6 pads here, and so on and so forth. And that's what we've basically been playing with to see how these things work. So again, the attributes are all about the characteristics of the objects that you've got. And I think I'll give a couple of other examples over here to just kind of solidify that point. I'm going to jump over here because there's some really cool features in here. One of them is electrical. Very, very useful. What if I've got all of these different lines and, well, they're not lines, they're all tracks, but they're all over the place in different layers. I only want those things that are part of the net list. Well, is electrical, that's an attribute. Right? So as long as it has something that's other than no net, it will find it and it will select those things. Another one that's kind of useful is free. So maybe I don't want to select those things that are part of the net list. So when I do apply all, it selects everything else that I've added onto this layout that has nothing to do with any of my schematic documents or the resulting net list. Another one that's kind of interesting, we just went into this whole rigmarole about enumerated types, but also in here is one that you may recognize, is standard component. And we do apply all. So this is the exact same thing as component type equals standard. I didn't have to type in all that extra information. It's already in here. So again, be careful and on the lookout for those type of things that are synonyms to each other. One of them, which we saw earlier, happened to be very specific to the properties. right? And that's under fields. And the other one here happens to be an attribute. Again, a characteristic of the component. And that's what the attribute checks are all about. Let's talk about parameters now. So parameters, there's a few of them in here. The two I would like to talk about are the has parameter and has parameter value. I also want to make mention of something that you may or may have not recognized, because I know there's a lot of people still transitioning between Altium 17 into 18 and in 19. In the past, in 17 and prior, the only thing that got pushed from the schematic side to the PCB side was this thing called a comment. And what we used to tell people in library management class is that, hey, if you got a good description, copy it into the comment, because a comment will find its way into the layout, and then when you look at the properties, you have a pretty good idea of what that footprint represents. Well, along the way, Altium decided, because I know a lot of people had asked for this, and it's been a long time coming, but they did it. What they said is like, hey, look, why don't you show me what the parameters are for that footprint in the layout that come from the schematic side? And I remember Altium being very resigned about resistant to this. And the reason they were resistant is what they did not want to do is have people change those parameters and push them back to the schematic side, where now you may have compromised the bill of materials. So what they agreed to is they said, okay, we'll give you the information. As a matter of fact, if you look in the properties under parameters, you can see all of the parameters. But what they will not allow me to do is make any changes to them. I can't add any, and I can't change them. Can't delete them as well. So there's no fields over here for that type of editing. And this is really great, because now you can do some really cool things with this. If you think about it for a moment, one of the biggest problems that you have with a lot of rules is that you have to make sure that your rules always have the same names, especially if you're going to use a rule that has classes. But now what you can do is, if your parameters in your library have the right information, that would propagate into the schematic, which in turn would propagate to the layout, and now you could actually create rules that are based off of this parametric information, and it can key off of that instead. So something to definitely think about. So a little bit of early planning there can help save you a lot of time in the long run with things being reused over and over again, the rules. Let's give some examples here. So I mentioned has parameter, so we'll bring that one here. So has parameter is cool. It's kind of like it's very much like the memberships, that it already gives you a list of those things that are available. So I don't have to go into the properties and figure out the name of it and type it in myself. In this example, I'm going to use the name example. So in P1 through P4, I did use a parameter name called example, and I have this value in there. Each one of them has a slightly different name to it, but that's what I put in here on the schematic. I put it on the schematic side, pushed it over to the layout side. Now I'm going to hit example here, and I'm going to press apply to all. So this particular query is going to find those things that have this parameter. It doesn't talk anything about the actual value of those. It's just looking for those that actually have this particular parameter. But if I do want to find the parameter as well, then we can do has, and we can type in parameter value, and there it is. And again, it gives me, it's basically a two-part parameter. So give me at least the list to pick the name of it. But when it comes to the value, I'm on the hook for that one. So I'm going to type in this is P3. And if I typed it in properly and I hit apply all, didn't like that there. Oh, because we forgot to end it. There we go. So we got to end that parentheses, and we hit it, and now it finds P3, because if we look in its properties, we look at example, and there's the value. This is P3. So there it gives you an idea of some of the parameter capabilities that you can use now, especially that these parameters are all available from Altium 18 and going forward. The next category are your layers. Actually, before I go into the layers, I'm going to jump down just so we can have some fun over here. And I'm going to talk about the system functions. So in the system functions, you have all the different mathematical features that can do some really good crunching for you above adding, subtracting, multiplying, and dividing. And there they are. You can do this. Now here's kind of the rub. In the filter panel, you're not going to get a number, at least not a number that you can see. So you can't do some type of equation over here and expect it to come back with a number. What it can do is that if you want to use these, you'll get a number, but it's immediately going to apply it to the query, and then it's going to determine if the query is true or false. And a really good example of that over here is one we showed in the last webinar, but we'll bring it up because it's a favorite of mine, is this one over here. This was the one where they used both the square and the square root. So let's apply the expression so we can take a look at it. So we have an is track and we have a logical and, but let's look at the rest of this that's in parentheses. We have a square feature. So, and we have x1, x2, y1, y2. Remember, these were properties. So it's looking for those properties that have x1 and x2 and y1 and y2. And now it's trying to put this into a mathematical formula. So we first square these, and then we take the square root of the entire equation, and then we determine if it is less than 2. This is the classic distance equation between 2 points. And you can see that it did find those things over here. So those that are tracks and those that are less than 2. So there's a great example of mathematical formula in work. In a moment, I'm going to show you something where you don't even have to type this in. But for now, just want to show you that you can do mathematical functions in here. That takes me over to the layers. So let's talk about the helper again into the layer checks. Some of these are going to be straight up booleans. They don't require additional information because they are specialized layers. On top layer, on top paste, on bottom solder mask. Those are things that don't require additional information because it's pretty obvious what you're talking about in terms of layers. Some of them do require additional information. Let's talk about those here or give an example of those. Let's press cancel. So sticking with this here, I'm going to say and it is, or pardon me, it's going to be on top layer. There we go, on top layer. And when we press apply to all, it has now found only that thing that is on the top layer. Now I did put one here on layer 1. And if I want to access that, I can. And there's a different feature, which interestingly enough is not currently in the query helper. It is called on layer. So we'll do on layer. And we will basically put this, it's like a function. So we have to give it its name. And again, we have to type it in right or it won't find it at all. And in this case, we did type it in correctly. And there it is, layer space 1. And this one gave us a devil of a time because we didn't realize that there was actually a space between the layer and the 1. But again, if you don't put it in exactly the way it's written in the layer stack manager, it's not going to work. So let's hit clear and try that again. There it is. It doesn't work because we don't have the right name. So you literally have to be literal about it. So there we go. Apply all, and it now selects it. So there gives you an idea of the different layers that you have here. What I'm going to talk about now are those operators. And you've already seen a good chunk of them. They should be pretty straightforward and intuitive, but I'm going to bring up my PowerPoint just to review them. There may be a few that you don't know about and some that I'll certainly demonstrate here in just a moment. But let's take a look at our PowerPoint. Let's jump on. This is everything we covered over here. The only reason that you didn't see these particular slides, I didn't want to keep jumping back and forth here, but everything I've talked about so far is the exact same thing you would have seen on these slides. There we go. Let's talk about the operator. Your typical mathematical operator. So if you are doing some type of, or requires some type of numerical parameter that has to be applied to the operators, they're the things that you can use. All right, so you also have one that's called div, which is integral division. So if it has any type of fraction after the decimal place, it'll drop it off and just simply give you the whole number. Modulus, this is basically remainder math, the type of math you do in 3rd grade. So if you have 13 divided by 3, you would have 4 remainder 1. What it would give you back is remainder 1. So the type of division that you would give a 3rd grader when they're first learning division and not having them stretch it beyond into some type of decimal. Your comparison operators, we've already talked about these. Just notice one thing is that the equal sign must be on the left side, or pardon me, on the right side. It cannot start first or it will not work. There's also one called not equal to, and there's also one called not, which we'll see here as well. So you can look for things that are not equal to what you are looking for. There are also logical operators. These are the ones you'll probably use most because the queries operate off of logical operators. You have and you have or. We've already seen that here in the last example. But also note that they have what's called a double and they have what's called a double pipe. These are not direct substitutes. There's some issues with these. In particular, they are given the lowest, I don't even say a lower precedent, they are really given the lowest of precedents. And I'll show you the list, the precedence list of operators here in just a moment. But they have the very bottom of it. So don't think by putting a double and in here that you're substituting. It's not. It actually gives it a very different feel, and it may respond differently than what you expected because of the order of precedence. The other thing here with the OR is there's this thing called a double pipe. The biggest problem with this one is that if you're importing and exporting rules, guess what they used as a delimiter? They used a single pipe as a delimiter. So if you use a double pipe, it's going to be an issue. That's something I did find in the bug crunch. So be aware of it. If you can try to avoid the double pipe, all the better. And if you can't avoid it, be very careful about importing and exporting your rules. There's also an exclusive NOR if you want to use that as well. And you can also use not. So we've been doing so far things like is via or is pad or is track. But you can put a not in front of it and you can negate it. There's also equal to, which we've seen quite a bit as well. There's also some other features like between and. I really like this one because, for example, if we're going to do the arc radius and we want to have a range, if we didn't have this between and feature, we would have to say arc radius is greater than 10 and arc radius is less than, let's say, 50. I don't have to type that anymore. Now I can just say arc radius between 10 and 50 and it'll do the exact same thing. There's another feature called like. I'll definitely demonstrate this here in just a moment. This one lets us get away with a little more slop when we're dealing with strings. So if we use like, we get to introduce what they call the wildcards. And there are two of them here. One of them is the question mark, which allows you to replace one character. And then there is the asterisk, which to me has always been what I call the true wildcard. It allows you to place one or more characters wherever it's been placed. Okay, so that's it gives you a lot more freedom, and I'll demonstrate that one here as well. The Boolean strings, we've seen this quite a bit already, but just to let you know, you can actually type this out as is via equals true. You can also type it in as is via equals false. You can also say not is via as well. So to me, it's just simple enough to type in is via or not is via, and that's just the way I'd probably do my Boolean strings, but to each their own. They've got a number of ways to do it. And the last thing I want to show you here before we jump back in Altium Designer to demonstrate some of these things is the order of operation. This is not the classic, please excuse my dear Aunt Sally. It has some things in here that are a little bit different because they also throw in the logical and the or. Notice that the double and percent and the double pipe are at the very bottom. So again, don't just do a direct substitution of these because you will change the order of operation. Okay, with that, let's jump back into Altium and show a few more examples. The ones that I would like to show you over here is between and. So let's go back to the one that we've done before. So instead of doing is arc, I'm going to show you one called Manhat, which is really cool. Manhattan length. It's called Manhat, and it's an attribute. So if we type in Manhat, and I want to find those things that have a length, those tracks that have a length between, say, 10 and 100, I can type that in. So I'm going to say Manhat between 10 and 100. And if I press apply all, it'll find all those track lengths that are between these two values over here. Now granted, if I want to find those things that are only electrical, I could say also is electrical. And then it'll find only those things that happen to fall under there. In this case, really, really small things that happen to have been created here. Also notice, Manhattan only works on tracks. It does not work on arcs. So be aware of that. But that's the example of the between and feature. The other one that's really cool, again, is the like one. So let's go back to this component equals. We did this one earlier and I told you had to be really careful about it. But instead of saying component equals, I can say component like. And then from there, I can start using my wildcards. So if I do component like and I put instead of a number a question mark and I do apply all, it finds all of these. Now if I did have something like P10, it wouldn't find P10 because this question mark only represents one character. And just to demonstrate that, if I do a D question mark and I do apply all, it won't find designator 6 because again it only represents one character. If I use the wildcard, it will find it because again it can be one or more characters that it looks for afterwards. So a nice way to make use of this feature as well. Again, I kind of like the other one where if you type in component, then it gives you a nice list that you can pull from. But you can see again a lot of synonyms that you can find throughout here. Well, with that, there's always more things that we can talk about here, but the time is getting a little bit short. And if you don't mind, I'd just like to say a few things about 9.connects. You're attending this webinar for a reason. Number one, you're really trying to understand the query language. And not just number one, it's really the reason you are here is to attend Roy, cut that part. You're here for a reason. You're here because you want a better understanding of the query language. And what do we mean by that? Because you know, and this is very true in printed circuit board design, if you understand it, it allows you to control it rather than it controls you. How many times have we done a query or we've been so reliant on the tool because we didn't understand the query? So it's like, look, I wanted to stay within this area over here. And the minute I've got to step out of the prefabbed queries that I can do with the find similar objects, with the filter panel, the minute I start using those things above and beyond, it gets a little nerve-wracking. What we want to show you is that these queries are there to help you. And hopefully by now you see how Altium set them up. It's not that hard to try them out. And by the way, if you're going to create a rule, always start in the filter panel. If you start in the filter panel, then you can ultimately create an expression afterwards from what you've been able to select using the filter panel. Right? So now you know how to control it rather than it controlling you. What do we do here at 9.connects? Well, there's a lot of different things, but what I want to talk to you about today is our on-site training. And this has become more and more popular over time. And there's a lot of really great advantages to it, and it doesn't cost much more, if actually it doesn't even cost more than what we do public trainings. Because it allows you, number one, to focus on your specific needs. You know that when you're in a public training, you're vying for the instructor's time with other people who also have other questions as well. But when we're on site, we can focus on your needs. Secondly, you can talk more openly about your needs. So if you have sensitive information or you kind of don't want to necessarily expose your workflow to other people that you don't know, then by us being on site, you can talk more openly about the specific needs. And by the way, we can custom tailor to a lot of needs as well. A lot of times we go in, we ask, is there something specific or do we have to focus on an area more so than others? And we can do that. We can't really do that in a public training because it would be too difficult to try to accommodate everyone. And lastly, it allows you to converse with your colleagues on workflows. I can't tell you how many times I've been in a training where all of a sudden a 15-minute conversation breaks out because I showed a feature and they realize that this will remedy some hassle that they've had to deal with for quite a long time on several different projects, and they get together and they start talking about that and they come up with a solution. And a few times they've said that alone was worth the entire training. So consider on-site if you're looking for some training needs. For more information, check us out here at 9.connects.com and you'll find out more about it. And again, if you don't necessarily see what you're looking for, don't hesitate to contact us. Our intent is to be able to try to educate you. And if we can't do it, we'll simply not be able to, or we'll try to redirect you to someone who can. But more often than not, we can accommodate your needs, especially in Altium Designer and in PCB design. And with that, I want to thank you very much for your time, and we will see you at our next webinar.